Yeah, hi guys. Today we are going to discuss about the SSL decryption. Okay. Our agenda of this class is we need to know what is decryption first. Okay. And what is the SSL decryption? What is the purpose of this? And what are the methods that are there in the SSL decryption? Okay. We have three types of SSL decryptions in the Palo Alto. One is an SSL forward proxy. Second one is an SSL inbound inspection, and third one is an SSS proxy. First two are belongs to the SSL. Okay, SSL means secure socket layer, and this is an SSH. Okay, SSH where you can securely connect to the CLA of any of the device. Okay, so basically, we can mostly focus on the first two things, forward proxy and inbound inspection. Okay. So the first thing is you need to know what is decryption first. Okay. So what is the decryption in the firewalls? Okay. Not only Palo Alto, in you can take any firewall. What decryption will do? Okay. So whenever traffic receiving, if the whenever the traffic receives the firewall, if the traffic is encrypted means the plain text, okay, whatever the message that you are sending, that is in the plain text means whatever we can see and we can read. Okay, so what encryption will do is the encryption will convert that plain text into some cryptographic algorithms. Okay, cryptographic text. So if if that is encrypted, no one can read. Okay, if no one can read, and only who have access to those information, they can only read. Okay, so how they can read means they have to do an decryption. Okay, decryption means this is a reverse process of encryption. So in the decryption, what it will do, the cryptographic text will be converted again into the plain text. Okay, so how this encryption and decryption will do means we have two types of encryption and decryption. Okay, using one thing is an symmetric using symmetric keys, and second thing is an asymmetric keys. Okay, I will tell you. One thing is an encryption. Okay, encryption means converting plain text into cryptographic text. Okay, cryptographic text means something which we can't read. Okay, for suppose if you send an text like, hi, I am ABC. Okay, so what encryption will do is this message will be converted into some numericals, so some special characters. Okay, like this. Okay, yes. Yeah, actually I think you have to see here, you have to minimize these things. Okay, is everyone facing the same issue, or how? Hello, can anyone confirm if you are seeing the screen small, or how you are visible? Yeah, see here, I think who is facing issue? Hello. Yeah, Vinay. Okay, okay. See here, you what you can do is you can just do in full. You can view in the full screen. Okay, or otherwise you have to remove all these participants. I think you can do it from the change layout. Okay, in the change layout you can have this. Go to the spotlight or something that you can see, like, or otherwise sidebar. Okay, just do that. Yeah. See here, here in the encryption, what encryption will do is the encryption will convert the plain text into the some cryptographic text. Cryptographic text, it will contain all the special characters, numerical values. Okay, so whatever we are sending out, it will be in the form of cryptographic text. And once this encrypted text receives on the firewall or received on the any security device, what they have to do is, if they want to understand what is inside this, they have to decrypt. Okay, which is called a decryption. Decryption means this is a reverse process of encryption. Okay, converting cryptographic text, okay, into the plain text. Okay, what it will do means, whatever the things that it is receiving, it will be converting into the normal form. Okay, this is the process of encryption and decryption. So how this encryption and decryption will work means, we have two keys. Okay, one is an public key and other one is an private key. Okay, these public keys and private keys will be used to do an encryption and decryption. Okay, how it will do means, this public key will be used, public key will be used for encryption. Okay, every device, okay, every device that supports decryption and encryption will be having its own public key and private key. So every device uses its public key to encrypt the data, and the private key, okay, and the private key will be used for decryption. Okay, let's suppose, take this is system A and this is system B. Okay, each having its own public key. Okay, public key and private key. So I want to send some information to system B. Okay, let's suppose, take this as an A and this is B. I want to send some information to system B which is over the public, okay, over the internet. So if you are sending, I want to send it in an secret, or no one want to see what is inside in my message. Okay, so what it can do means, it can generate a message like, suppose, hi, I am ABC, and what it will do means, if no one want to see, what they will do is, they will use a public key and encrypt the message. Okay, encrypt the message and it will send here. Okay, if anyone sitting here, if anyone sitting in the internet and they want to access this, they want the private key to decrypt. Okay, so the private key will be available on the system A and system B only, but if they have the private key, that private key won't be suitable for decrypting this. Okay, so in order to decrypt this, they have its own private key. So whenever they are sending out to the system B, the system B receives this message, right? The system B receives this message and it will use its own private key. Okay, this will also having private key. Okay, this will also having its private key and it will use its private key to decrypt this and decrypt this and read the message. Okay, and in the same time, if system B wants to send a message over the public in a secure manner, what it will do means, it will also encrypt this message. Okay, and using a public key. Okay, it will also decrypt, it will also encrypt the message using a public key and it will send over the public. Okay, it will send over the public and this reaches the system A, and it has its own private key, right? So it will decrypt this using its own private key and read the message. Okay, this is how encryption and decryption will work, and the use of the public key and private keys. Okay, we have two keys, public key and private key. Public key will use for encryption, private key use for the decryption. Okay, and this is for the what is the decryption and what is the purpose of SSL decryption. Okay, SSL decryption mainly used for the web traffic. whatever the things that you are browsing on the internet. Okay, see, for suppose if you want to open any Facebook or Instagram or Snapchat, what you will do, you can go with facebook.com, right? But underlying protocol it will be using is an SSL. Okay, SSL, and as well as what the SSL will be used an HTTPS. Okay, SSL will be using an HTTPS, which is an port number 443. Okay, so whenever you are typing facebook.com, in the backend what it will do means it will be using an HTTPS / facebook.com. Okay, if I let's see here, this is a browser, right? When I type facebook.com, so if you go with, see here, underlying protocol is an HTTPS. Okay, so HTTPS means we have uh, we have two things. Okay, one is an HTTP and other one is an HTTPS. HTTP is not secure. Okay, in order to secure our traffic, we can use an HTTPS. All web traffic nowadays, all the web traffic is going over the HTTPS only. Okay, so if you are using HTTPS, whatever the things that we are browsing, that will be going into the internet in an encrypted format. Okay, so for suppose we have a firewall and we have a Windows machine, we are connected the Windows machine to the firewall, and we have a firewall that is connected to the internet. Okay, so for suppose you are browsing HTTPS colon www.facebook.com. Okay, you are browsing www.facebook.com. You are initiated the traffic using Google Chrome or any other web browser in the Windows machine or whatever the system that you have. Okay, whenever the traffic reaches the firewall, what firewall will do in order to identify the traffic? Okay, because we are using HTTPS, whatever the traffic we are sending using HTTPS, that will be in the encrypted format. Okay, so what it will do means the firewall has to be, because the firewall, why we are using firewall, the firewall is there in your network in order to inspect the traffic that is flowing inside and outside of your network, right? So in order to identify the traffic, so in order to identify what is the traffic that you are using, the firewall will decrypt here. Okay, the firewall will decrypt here, which is an HTTPS traffic. Okay, all the web traffic that firewall is doing comes under the SSL decryption. Okay, SSL decryption. Okay, so once the firewall decrypt the traffic and inspect that, okay, what is the application that they are using here, and the firewall decrypt the traffic and it will identify they are using www.facebook.com. Okay, and once it identify the facebook.com, it will be checking the security policies here. Okay, security policies, if this facebook.com is allowed in the security policy or not. Okay, so if we have configured a policy that allows the facebook.com, it will allow the traffic out, otherwise it will drop the traffic. Okay, so why we are using SSL decryption means whenever you are browsing something in the internet, it will be underlying protocol that is using as an HTTPS. When this HTTPS traffic receives a firewall, the firewall has to be decrypted, right? So for the decryption, we are using SSL decryption in the firewall. We have to configure SSL decryption in order to inspect the HTTPS traffic and in order to enforce the policies. So firewall will use an SSL decryption, and here what it will do means the firewall will act as a man in the middle. Okay, for I will tell you how this firewall will act as a man in the middle. Okay, understood, right? Why we are using SSL decryption in order to in order to decrypt the SSL traffic and whatever the HTTPS traffic that is receiving on the firewall, and it will inspect that what is the application that is in the what is the application that they are trying to access. Okay, so that is the purpose of SSL decryption here. Before going to the before going to the forward proxy or inbound inspection, or before going to the types of SSL decryption, you have to know the SSL handshake. Okay, SSL handshake. Okay, can anyone tell you when you are browsing www.google.com in your browser, what are the things that going to happen in the backend? Can anyone tell me the answer? If you are typing www.google.com, what is the backend process that it is what is the backend process that is proceeding with when you are browsing www.google.com? Can anyone? Yeah, Vinay, proceed. Go ahead. Yeah. Mm-hmm. Okay. Mm-hmm. How IP address will be identified? Yes. First thing it will be happen is DNS resolution. Okay. It will resolve the DNS. Okay. Next thing. Go ahead. Yeah. Yeah. Establishing TCP connection. Okay. That is called TCP handshake. Right. And after that, what it will do is the next process is an SSL handshake. Okay. See here, if you are browsing https colon colon www.google.com. Okay. If you are browsing https www.google.com, what it will do is first it will resolve the IP address for this particular www.google.com by sending an DNS request, and it will get an IP address. Once it gets the IP address, it will initiate an TCP handshake. Okay, TCP three-way handshake. Once the TCP three-way handshake completes, it will be moving to the SSL handshake. Okay, you have to know how the SSL handshake will work. Okay, see here we have, this is also same, the client and server model. We have a client, we have a server. Okay, we have a connection between client and the server. In the SSL handshake, we have multiple messages. Okay, the first thing is an client hello. Okay, which is an client hello. What happened in the client hello means, the client will generate a message called client hello to send to the server. Okay, to in order to send a client hello to the server, the client will have to will have to add some parameters in the client hello. Okay, what are the parameters that will add means, it will add the TLS versions. Okay, for SSL, we will be calling as an TLS versions. Okay, SSL or TLS versions. We have multiple TLS versions. Okay, we have TLS 1.0, TLS 1.1, TLS 1.2, and the last one is TLS 1.3. Now the latest one is in TLS 1.3. Okay, whatever the TLS version that client supports, it will add in the client hello, and apart from that, it will also add cipher suits. Okay, what are the cipher suits means, the cipher suits is a combination of we have an authenticate, we have multiple algorithms. Okay, we discuss about the encryption decryption, right? If you want to encrypt and decrypt, we need an public and private key. Those are we'll calling as an encryption algorithms. Okay, encryption algorithms, combination of encryption algorithms. Okay, hashing algorithms. Okay, and also authentication algorithms. The cipher suits is a combination of all these things. Okay, and it will add all the cipher suits which are supported by the client. It will add in the client hello, and the last one it will add is client random. Okay, client random is, this is a random string that will be adding by the client in the client hello. Okay, In the client hello, the client will add all these things and it will send to the server. Okay, it will send to the server. The server receives this client hello, and in response this it will send an server hello. Okay, second from the second message. Okay, the second message is from the server. It will send an, sorry, server hello. Okay, what server will do means, the server will receive all this information, right? The CA TLS versions and the cipher suits. Okay, the cipher suits, maybe the the client will supports, for suppose the client will support 16 cipher suits, for example. It will send all 16 cipher suits and it will send all the TLS version that it supports and the client random. Okay, what server will do means, server will select one TLS versions that server supports. Okay, for suppose server supports TLS 1.2. Okay, TLS 1.2, that will include in the server hello. And here we have 16 cipher suits, right? If the server supports only one cipher suit, any one of the cipher suits in the uh, in 16 cipher suit, it will select that one cipher suit and place it in the server hello. And also it will also send an server random, which is an the random string that is sending by the server to the client. Okay, apart from that, what it will send is, the server will send server certificate. Okay, server certificate, along with that it will send an public key. Okay, why we use public key? We will be using public key for encryption, right? This public key will be used in the further process in the SSL handshake. Okay, just remember that in the server hello, along with the server hello, it will send an server certificate, public key. Okay, and also it will send an server hello done. Okay, with this server hello done will send by the server. Okay, this is an server hello, and along with the server hello it will send an server certificate, public key and the server hello done to the client. Okay, once the client receives this server hello, what it will do means, it will be check the server certificate. Why certificate will be using means, certificate will be using for authentication of the server. Okay, certificate will be used for authentication of server. Why we need authentication? We need authentication because the client has to be trust the server. Okay, when whatever the traffic receiving in the files, receiving from the server, the client has to be trust, right? If the client is not trusting that traffic, it won't send, it won't accept the traffic. Okay, so in order to trust the in order to trust the traffic from the server, the client, what the client will do means, the client first authenticate with the server with the certificate. Once the client authenticate with the server, so the next traffic will be trusted by the client. Okay, so in order to trust the traffic from the from the server, the client has to be authenticate first. Once authentication is done, the whatever the traffic coming from the server to the client will trust all the certificate, because we have to know whether the traffic is receiving from the legitimate server. For suppose this is the internet, right? For suppose if you have any other servers. Okay, and this server is responding. Okay, we are sending this client hello to the internet. We don't know whether it has received by the legitimate server or it has to be received by the any duplicate server. Okay, but both the server will send an server hello, and this is also send an server hello, right? So in order to identify we have received the traffic with the in order to know we have received the traffic from the legitimate server, we need to authenticate first. Okay, so in order to authenticate we need a certificate. This certificate will be used here to authenticate the server. Okay, so after authentication, what it will do means, the client will also send, this is an optional one. Okay, if the server has to be authenticate with the client also, the client will send its certificate. Okay, certificate, and it will send client hello done, client hello done. Okay, this is not mandatory. this client certificate is not mandatory because the server don't want to trust the client. Okay, we have to, because this is an the client will be in in the internal network, right? Whatever the clients will be available in the internet internal network, those are the legitimate only. Okay, but if there is a requirement to for the client authentication, so the client will send a certificate to the server, and this server hello done is sent to the server. Okay, here after this both will have it, the both client and server will have the certificate, right? So the client also will have client random, it's server random, right? And also server will also have the client random and server random. Okay, the client random will be sent by the client in the client hello, so it will be having the client random, and it has its own server random. Okay, next thing what it will do means the client will send an the client will generate an pre shared key. Okay, we will be calling as an PSK, which is an pre shared key. The client it generates its own pre shared key, and it will be sending this pre shared key will send to the server. Okay, how it will send means this pre shared key will be encrypted using public key. We have received the public key here, right? We have received the public key along with the certificate, right? So this public key will be used by the client in order to encrypt this pre-shared key. Okay, the public key will be used, the public key will be used in order to encrypt this, and this sent to the server. Okay, this encrypted pre-shared key is received by the server. We have encrypted PSK, which is an pre-shared key. What server will do means server will encrypted. Okay, sorry, decrypting using its private key. Client and server will have its own public key and private key. Okay, and the public key will be shared and private key will not be shared. Okay, because in the name itself we will be seeing, right, which is an public. Okay, public key means it will be shared in the public, but private key should not be shared. If you share the private key, there will be a chance of compromising your network. Okay, so once the encrypted pre-shared key received by the server will decrypt it using its private key, and it will be seeing this pre-shared key. Okay, now the client and server will be having client random, server random, and pre-shared key, right? So here also having client random, server random, and pre-shared key. So using all these three things, what server and client and server will do means the client and server will generate an session keys. Okay, using the, just let's take client random plus server random plus pre-shared key. Using all these three things, the client and server will generate an session keys. This server also will generate the same thing, and these session keys will be used for further process. Okay, further process in the sense, once the SSL handshake completes, both will be agreeing that they can share the information in a secure format. Okay, this here, this is our this is our client, this is our server, right? And once the session is created, both client and server will agree we can exchange the information in a secure format. There will be an one tunnel will be formed, which is an SSL tunnel, and in the SSL tunnel the actual data will be formed. Okay, the actual data will be formed, and using these session keys the client will encrypt that. Okay, now here the public key and private key will not be used. Okay, for encryption and decryption, after forming an session keys, the session keys will be further used for encryption and decryption. Okay, here SSL tunnel will be formed, and whenever the client send an traffic, or whenever the client send the data, it will be encrypted using a session keys, and this traffic, whatever the data will be received by the server, this session keys, okay, we have a session key in the server as well, right? This session key will be used to decrypt the traffic, okay, decrypt the data, and the server will read that data, okay. So once these session keys are generated, both will exchange the finish message, okay. After that it will send and finish, and it will also send the finish message, okay. With this, the SSL handshake will be done, and both will be agreed that we can be able to send an information or able to send the data in a secure format, okay. This is how SSL handshake will work, okay. Do you have any queries, or do you have any questions? Yeah, do you have any confusions anywhere in this SSL handshake? Yes, Vinay Kumar, you have raised your hand. Sorry, your voice is too low. Can you repeat the question once? Ah. Oh, okay. You need to know about SSL decryption. Okay. See here, we have a client. Okay, we have a client, and we have a firewall. And let's suppose, let's take, we have a server in the public. Okay. So the firewall needs to be understand what is the traffic, and what type of traffic the client is able to authentic, or are able to access. Okay. In order to know the firewall, the what firewall will the basic purpose of the firewall. What is the basic purpose of the firewall? The firewall has to be inspect the traffic, right? The firewall has to be inspect the traffic whatever the clients are accessing, okay. So whenever you are using HTTPS traffic, the all the traffic will be flown in the form of encrypted format, because HTTPS itself is an, S means here HTTP is a normal traffic, okay. Whenever you use HTTPS, S means here secure, okay? So whenever you are using HTTPS protocol, all the traffic that are flowing in the HTTPS will be in an encrypted format, okay. So whenever this encrypted traffic will receive the firewall, in order to inspect the traffic, the firewall has to be decrypt, right? So in that case, how the firewall will decrypt the traffic means they will be using an SSL decryption, okay. So here we need to configure an SSL decryption. So whenever you want to decrypt whatever the HTTPS that is receiving on the firewall, in order to decrypt that, we can use an SSL decryption, okay. If we configure SSL decryption, the firewall will be able to decrypt the traffic, and inspect the traffic, and identify what type of traffic that client is going to access, and it will be enforce the security policies, okay. If the security policies are not matching with this, if we have configured security policy to allow this www.facebook.com, the firewall will allow, okay. If it is not, if we have configured uh, to block the access to this client, the firewall will be drop the traffic here. It won't able to send the traffic out, okay. Basically the SSL decryption will be used in order to decrypt the HTTPS traffic, in order to inspect the traffic and enforce the policies, okay. This is the basic need of SSL decryption. If it is not HTTPS, if it is not HTTPS traffic, if it is an only plain traffic, we no need of an SSL decryption. If it is in plain traffic, it will directly enforce the policies, and it will going further, whether it is an allow or whether it is blocked. This SSL decryption will mainly for the whatever the thing that you are browsing on the web browsers. Okay. Yeah. Yes. Hmm. Yeah. It will go with the SSL handshake. Yes. No. It is both are not part of a SSL handshake. But before going to the SSL handshake, this has to be complete. If the TCP handshake is not completed, okay, TCP and we have a three-way handshake, right? If you have send SYN packet, okay, if you send SYN packet, if SYNAC is not receiving from the other end, we cannot establish the TCP connection, right? So if you are not able to connect the if you are not able to form the TCP connection, the SSL handshake also will not form. Yes. Yeah. Yeah. Mm. Mm. Mm-hmm. Mm. Yes. Yeah. 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 Yes. 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 Yeah, that's correct. Yeah. Yeah. Okay. Perfect. Yeah, this is about the SSL handshake, and we have discussed about SSL decryption also, right? So now we are entering into our main topic, which is our SSL decryption. What we have multiple methods, right? We have three types of methods in SSL decryption. One is an SSL forward proxy. Okay, first one is an SSL forward proxy. When we use SSL forward proxy, this is one type of one method in the SSL decryption. When we use this SSL forward proxy, okay, means when we use means whenever you are sending the traffic for this is for the outbound traffic, okay. Let's call it as an outbound traffic. Outbound traffic means whenever you are sending traffic from your private network to the public network or internet, okay. For suppose, let's take this is a firewall, okay. This is a client machine, and we have the server in the, let's take this is our internet, this is connected to the internet where the server is located, okay. Outbound traffic means whenever you are sending the traffic out from your private network. Private network means this is your private network. This is a public network. Whenever you are sending a traffic from your private network to public network, you need to configure or you need to enable the forward proxy. Okay, that is called an outbound traffic. Whenever you see the outbound traffic, whenever you see the HTTP traffic is outbound from your firewall or from your private network, you need to configure or you need to know that will be an forward proxy. It will use an forward proxy. How forward proxy will do means in the SSL handshake we just talked about client and server. We don't have any firewall in between, right? This is communication between the client and the server only. Okay. In the SSL decryption, what I told you, the in the SSL decryption, the firewall will be in the man in the middle. Okay. Man in the middle means it will be sitting in between the client and the server, in between the client and the server. Whatever the communication is happening between client and the server and server to the client, it will be checking, and it will be decrypting, and it will be inspecting all the traffic, okay. So what it will happen means whenever we are sending some traffic, let's take we have discussed about SSL decryption, right? Sorry, SSL handshake. So what it will do, the client will send a client hello, right? The client will send a client hello. What all the things we have discussed here in the client hello, all the things will be sent by the client to the server, okay. It will send client it will send the client hello to the server. What client will think means the client will think I send this client hello to the server, but this client and the server will don't know that firewall is in between, okay. This client think that I am sending client hello to the server, and the server also will think I am sending the server hello to the client, but with these don't know we have an firewall in between. The firewall will act as a man in the middle, and it will be a transparent between client and the server, okay. So we can also think that the firewall will be acting as an server to the client, okay, and also client to the server. How means whatever the client hello will be sent by the client, the firewall will receive the client hello. What it will do means once it receives the client hello, it will be generating the another client hello here with the same information. It won't modify any information, it will just inspect and it will be generating another client hello here, another client hello for the server. We have talked about this, right? This firewall will be acting as a server to the client and a client to the server. So that's why it will be taking this client hello and it will be taking the information from here and it will generate new client hello and it will include all the information what the client will send and send to the server. Okay, and the server will generate an server hello, right? The server will generate an server hello and all the things that we have discussed here in the server hello, including this TLS version, cipher source, server certificate, public key, server hello done, right? So here mostly you need to focus on the certificate, okay, server certificate, okay, server certificate. How the certificate is look like is, I will tell you how the certificate look like. In the certificate, what are the things that we have means, in the certificate we have issued to, issued by and validity. For every certificate we'll be having issued to, issued by and validity. Issued to means to whom you are, to whom you are sending this sending this certificate, okay, to whom you are generating this certificate. For suppose if you are browsing www.facebook.com, okay, what it will do means it will be issuing the certificates to the www.facebook.com, okay. The server will be issuing the certificate to the www.facebook.com. Let's suppose issued by, okay, issued by. In the in the internet, this issue there will be having multiple third party certificate, okay. One third party certificate will be an digicert, will be having digicert. Not only the digicert, there will be multiple third party vendors, we can call it as an certificate authorities, where they are providing the certificates, okay. So this certificate to the www.com is issued by the digicert and it will be having validity, okay. By default it will be having 365 days, okay. The validity will be like, if you think that today is 10/04/2025 to 10/04/2026, okay. By default the certificate will be valid up to 365 days, okay. So the certificate will be look like this, and whatever the we talked about the server certificate, right? The server certificate, it will be looking like this, okay. Once this server certificate along with the public key in the server hello, public key is sent by the server to the client, okay. It will be sending the server to the client. So in between the firewall will inspect this, okay. So what firewall will do means, the firewall will inspect this certificate. How firewall will inspect the certificate means, it will check its issued by field, okay. In the firewall will be having default trust, okay. We can call it as an default trust root certificate store, okay, okay. So in the firewall, we will be having default root certificate store. What available? What are the things available in the default trust root certificate means? All the third party certificate authorities. Okay, all the third party certificates or all the root CS will be available. Okay, all the root CS or third party CS. So CS means certificate authorities are available in the trusted root certificate store. What firewall will do means, once this server hello reaches the firewall, it will inspect the certificate. What it will inspect the certificate means, it will inspect the issued by field. Who is issued by? It is the certificate is issued by digicert. If DigiCert is available in the default trust root certificate store. Okay, if DigiCert is available in the default trust certificate store, what firewall will do means the firewall will send its own certificate. Okay, we will be having two certificate in the firewall, which is an forward trust certificate, and we'll be having another one more certificate called forward untrust certificate. Okay, it will check this certificate whatever the server sends, and it will check the issued by field. If issued by field, okay, for suppose we are talking about DigiCert, right? If DigiCert is available in the firewall trust root certificate store, it will be sending, the firewall is trusting the this firewall is trusting the server, and it will be send the forward trust certificate. Okay, we have to create this certificate. Okay, we have to create this. I will show you how can we create a certificate in the firewall while doing this SSL decryption lab. We need to create forward trust certificate, and we need to create forward untrust certificate. So what firewall will do means firewall will send it forward trust certificate, because this issued by field, which is an DigiCert, is available in the default trust root certificate store. So the firewall think that I am trusting the traffic that is sending the sent by the server. So I am sending the trust certificate to the client. Okay, what it will do means it will be generating an server hello here, right? The firewall will generate an server hello, because this firewall is acting as a server to the client, right? Whatever the server send, whatever the server hello sent by the server, what it will do, it will just modify the certificate here. Okay, it will just modify the certificate. It will be placing all the TLS versions, okay, and cipher suits that sent by the server. It will kept as it is. What it will do means it will just modify the certificate. It will instead of sending a server certificate, it will send an forward trust certificate. Okay, trust certificate in the client hello, and this server hello is sent to the client. Okay, how the client will trust whether it is legitimate traffic or not means it will also verify the certificate that is sent by the server. It is thinking the client will think that I have received the server hello from the server only, but this doesn't know it is getting from the firewall. Okay, so what it will do means it will be checking the certificate, and it will see the forward trust certificate, right? So it will be thinking that we have it is a trust certificate, and it is also trusting the traffic, that is the whatever the information or whatever the data that is receiving from the server is legitimate. Okay, so after that everything will be flown as it is. Okay, next we have a pre-shared key, right? It will send a pre-shared key, and it will the firewall receives. Okay, the firewall receives, and it will be it will what it will do means it will not modifying anything. It as it is, it will sending a pre-shared key here, and it will be generating all the session keys, and it will also generating the session keys. Okay, and we are forming an SSL tunnel between client and the firewall, and firewall and the server. Okay, so we are forming an secure tunnel between client and the server, in between having an firewall in between. Okay, so whatever the traffic that is flowing from client and the server will be decrypting and inspecting by the firewall. Okay, so that is how the SSL forward proxy will be worked here. Okay, do you have any clarifications or any confusions here in the forward proxy? This is basically depends upon your depends upon the SSL handshake only. Whatever the things happening in the SSL handshake, it will be happening in the SSL forward proxy. Okay, the why we are using SSL forward proxy means whenever you are sending in traffic out, okay, from your private network to the public network, then you can have to use a forward proxy. Rest of the things will be same as it is an SSL handshake only. Okay, once everything is shared, it will be forming an SSL tunnel between a client and the server using an firewall. So whatever the traffic sending from client and the server, the firewall will decrypt that, will inspect that, and will enforce the policies. Okay, hey, do you have any questions or do you have any queries on this forward proxy? Any questions? These forward trust and forward untrust certificates we have to create in the firewall. Okay, we have to configure in the firewall. So once this firewall trusting this server certificate, it will modify this certificate. Okay, it will modify this certificate and it will be sending it replacing the server certificate with its own certificate. Okay, with its own certificate which is in forward trust, and it will sending to the client. Okay, that is the thing that you have to remember here. Okay, that is the basic difference between when there is a firewall in between client and the server and when there is no firewall in between client and server. Because the firewall has to be inspect, right? And so that is the that is why the firewall sending its own certificate to the clients. Okay. So if you have no doubts, you can proceed with the next method, which is an okay, which is an inbound inspection. SSL inbound inspection. You can say this. Okay, why we use inbound inspection means whenever you see the traffic is inbounding. Okay, inbounding means when the traffic is coming from outside to the inside. Okay, in this case the scenario is different. Okay, the scenario is reverse. We'll be having the firewall, we'll be having the client in the outside. Okay, we'll have the server inside of the network. Okay, this situation will arise when you are working. Let's take whenever you are working from home. Okay, whenever you are working from home, you will be in the internet. Okay, you will be in the public and your traffic is coming to the public and it will be receiving the internal network, which is an your office network. We will be considering as an internal network as an office network, and you are coming, your traffic is coming from public. Okay, so whenever you are initiating the traffic, it is coming from outside to inside, right? So in that case what we'll do means we have to configure inbound inspection. Whenever traffic coming from inside to outside to inside, you need to configure SSL inbound inspection. That is why the name itself will be seeing inbound inspection. Whenever traffic inbounding your private network, you need to enable SSL inbound inspection. Here the topic is simple. Okay, we before starting the starting the communication, what we have to do is we have a server certificate, right? For every server we'll be having server certificate. Whatever the server certificate that we have in the server, we have to install in the firewall along with the public key. Okay, along with the public key we are installing the certificate in the firewall. Why? Why means here in the forward proxy, in the forward proxy the server is outside, so we cannot trust that server. In order to trust that, the server has to be send the certificate in order to trust that server is legitimate or not. But in this case the server is inside. Where the server is inside means we know how the server behaves and we know how the server reacts to the traffic. Okay, because this is in the trusted network and we know how the server behaves. So what we are doing is we are directly going ahead and installing the server certificate in the firewall along with the public key. Okay, so whatever the client, whatever the communication that is receiving, the firewall will be sending it. See here, it will send a client hello to the firewall. The firewall will send a client hello to the server, and the server will send an server hello. Now in this case what it will do means it won't send a server certificate because it is already we have sent an the server will have sent we have already installed the server certificate it, right? So it will send an only the TLS version so it will supports. And once the server sends an certificate sends a server hello, what the firewall will do means the firewall will include this certificate. Okay, include this certificate in the server hello. It will be generating an again server hello, right? It will generate a server hello, it will include this certificate in the server hello, and it will be sent to the client. Okay, so the server will be, the client will be trusting the client will authenticate the server using this certificate, and next things it will be the next things it will be after everything it will share the pre-shared key, session keys, everything. It will be forming a tunnel between server and the client and the server. Okay. So and everything rest is rest everything will be same. Okay. The basic difference between forward proxy and inbound inspection means this certificate only. In the forward proxy, we have to create a own certificate in the firewall, and once the server send an server certificate, and we can check if if the certificate is trusted or not by checking the issued by field. Okay, whatever the issued by field is there, if it is available in the default trust certificate store of the firewall, if it is available, it will sending an trust certificate, right? So in this case, this is the reversing. We have already known the server is already, we are trusting the server because it is already in the inside network, which we can trust that servers and we can know how the server behaves. So we are directly installing the certificate. Okay, this certificate will be sent by the firewall to the client, and the client will use this certificate to authenticate with the server. Okay, so this is all about the SSL inbound inspection. And we have one more thing is an SSH proxy, right? This SSH proxy is not much using right now. Okay, but to have an idea about this SSH proxy, you can also do the same thing. Okay, we have a firewall, and we have a client, and we have a server. If you want to do SSH of this server, not only server, if you have any device, okay, if you want to do an SSH of this device in a secure manner, we can use an SSH proxy. What it will do means the client will send an SSH request to the device or the server that is available in the public. Okay, what it will do means along with the request, this SSH will be having some RSA keys. Okay, so these RSA keys, if the firewall will have this RSA key that is sent by the client along with the SSH request, it will sending a request out to the server or the device that they are communicating. Okay, and if there is no RSA keys, or if there is no keys that are sent by the client is not available in the firewall will not send an SSH request. So it will not form any it will not send an any SSH request outside of the firewall. Okay, so if there are any if there are RSA keys available, and the firewall is able to make an SSH connection, it will be sending out, and it will also send an request. Okay, once the device and the server will get their request, it will be sending an response. Okay, it will sending an SSH response, and yeah, once the response will come from the server, it will be forming some same how the SSL tunnel will form. It will also form a secure connection between the our client and the devices which are available in the public. Okay, this is all about the SSH proxy, but these are not much not at all using right now, because SSH if we are using SSH, that is all that is will be an it will be using and secure only. So nowadays they are not using firewall or any firewall for the SSH proxy. Okay, because SSH itself is an secure way where you are connecting CLI of the firewall or CLI of any device in a secure manner. Okay, so SSL proxy will not be using much, but mostly we are going with forward proxy and inbound inspection only. Okay. Do you have any questions or any clarifications? Oh yes, yes, Vinay. Proxy means we are sending. See here, if you send a request in order, see, you are sending an request to the others. Okay, so you are sending a request to others. Besides the others, we are responding to these clients in besides of the request sent by the actual. Okay, for suppose we have three. Let's take we have three members. Okay, you are let's take A, B, C. You are sending a request to C, but what if you configure proxy on B? What B will do means B will respond instead of C to the A. Okay, That is basically the proxy will do. Nowadays, there are some proxy servers as well. If you configure a proxy servers, instead of sending a request to the original one, or you can send a request to the original server, but in between these proxy servers will involve, instead of getting a response from the original server, these proxy servers will respond to these sources or whoever sending a request. Understood? Yeah. Any other queries? Any other questions? Yeah, this is a SSL forward proxy. We'll be having client, firewall, and the server. The client initiate the SSL handshake. Okay, send an SSL connection, and the firewall will initiate a SSL session to the server. And when the server send an as a server hello, it will be checking the certificates. Okay, server certificate, and it will sending its own certificate to the client. Once the certificate receives the certificate received by the client will verify the certificate from whatever the received from the firewall, and it will form an secure tunnel. Okay, secure tunnel between client and the server, while our firewall in between. Okay, and this is also inbound inspection, which is our client will be in outside and the server will be in the inside. Okay, so what admin will do means admin will import the server certificate and key onto the firewall first, then only the communication will happen afterwards. And this is an SSH proxy. Okay, and SSH proxy, how I told you the same way, how SSL methods will be work, SSH proxy also will work in the same way. Okay, do you all have the access to the websites, right? You can, we have all these PPTs in the website. You can go ahead and download. You can also you can refer these PPTs. Okay, whenever you have any doubts, you can refer PPTs, and you can have the access to this video as well. I will share with you. Okay, and you have any queries or any questions on this SSL decryption methods? I think you are not aware of this terminology, but you have to understand this. Okay, you have to understand how decryption will work, how encryption will work, and what is public key, what is private key, why we can use public key and why we can use private key, and how SSL handshake will work. I think these are the new things for you, but if you are gone through these topics one or twice, you will get and familiar with this. Okay. Yes, Vinay Kumar, you have raised a hand. Go ahead. SSL certificates. See here, if you are browsing anything on the browser, right? If you click on this, whatever the thing that you are browsing, you have an left side, you on the top, on the left side of that URL, you will be having something, right? You can see here connection is secure. If you are seeing connection is secure, this my client is trusting the server, and my client means my piece, my laptop. Okay, my laptop is trusting the server, and my laptop is already authenticated with the server certificate. Okay, if you click on that connection is secure, it will show certificate is valid. Okay, if you click on this certificate, it will show this. See here, issued to what, to whom it is issuing, it is issuing to the facebook.com. So it, who it is issued by, it is issued by DigiCert SHA-2 High Assurance Server CA, which is an third party CA who is going to assign this certificate to www.paloalto, sorry, facebook.com. Okay, so on the validity, we will be having a validity period where maybe it will depends. Okay, it will depends upon the requirement and it will depends upon the customer. but basically this certificate will be valid by default 365 days, and they will be also having some agreement between the companies and the third party CAs who are signing the certificates, okay, or who are providing certificates. Based upon that, they will provide the validity, okay. So this is how certificate will look. Will be having issued to, issued by, and validity period. My client PC is my laptop is trusting this site and trusting this certificate because maybe my trusted root folder will be having DigiCert certificate. Let's see if you have DigiCert. You can also check in the laptop as well. See here, you can run in the run command. You will be having certmgr.msc. If you type certmgr.msc, it will take you to the laptop certificate store. Okay. See here we'll be having personal where you will be having server certificate. Okay. You have a trusted root certificate. Okay. If you click on the trusted root certificate, we'll be having all the trusted root certificate. Okay. You can search for any DigiCert. Okay. We'll be having DigiCert right here. You will search for DigiCert here. If DigiCert is available in this trusted root certificate, my laptop will trust this server, and my laptop will trust this certificate, and my laptop will trust whatever the traffic is receiving from the server, and it will made in secure communication. Okay. Let's see whether we have a DigiCert or not here. See here we'll be having DigiCert. See here we'll be having DigiCert high assurance. We'll be having two certificates. Okay. Let's take the details. Yeah. See here we'll be having we will be having three certificates. Okay. One is an server certificate, another one is an which is an intermediate, and this one is an root certificate. Okay. This will be signed by this intermediate certificate. This intermediate certificate will be signed by the root certificate. Okay. We are seeing this in the root certificate. What is the root certificate that we have? Root certificate is DigiCert High Assurance CV Root CA, right? See, this is the one DigiCert High Assurance Root CA. And we need, if we want to see the intermediate certificate also, we'll have an intermediate certificate authorities. Just click on the certificates. Just see here, we'll be, if you have any yeah, see here, this is the one which is a DigiCert, okay. So we have the DigiCert, whatever the certificate that are available in my laptop certificate store. So I'm trusting this. I'm trusting this server. I'm trusting this website. So I can make an secure communication between my laptop and my server. Okay. This is how you can verify. I will tell you once whenever we are doing lab. I will tell you how can you verify. So you already asked, right? I am showing you how can you verify whether how the certificate will be look like, and how the client will trust the certificates or trust the servers. Okay, understood, right? How the certificate look like. You can also import these certificates. Okay, if you see here, if you click on validate, you'll be having here, right? You have an option to export. If you click on export, it will be export to your local machine, and just whatever the name that you want. Okay, you can go with any base 64 only. Okay, you can go with base 64 point and save. It will be saved in your local machine. Okay, go on downloads. See here I have a server certificate, right? You can also check what are the fields. Whatever the thing that we have seen there, it will be also issued to, issued by, validity. These are all the details. And certificate path. Certificate path means who are the intermediate certificates and who are the root CAs. Okay, if you see the certificate is okay, I am trusting the certificate. Okay, whatever the whatever the PC or whatever the laptop the certificates is available, the certificate, the laptop or PC is able to trust the trust the server or trust the certificate. Okay, this is how you can view the certificates on your browser as well. Understood? Yeah. Any other questions? I will tell you how can we create a certificate in the firewall. Okay, no worry. If we, you can get the certificate in two ways. One, you can create your own certificates, or if you don't want to create your own certificates, if you have any contacts with the third party certificate authorities, you can contact them. You can provide your details to whom you want to get the certificate. You can provide your details so that they will be generating the certificate and they will be giving to you, and that certificate you have to install in the firewall. Okay, that is the process. You can get the certificate in two ways. You can locally create, or you can get from the third party certificate authorities. Okay. Any other questions? Okay guys, I will take it as no. Okay. If you don't have any queries, we can wind up this session. I am going to stop the recording for now.